Hey, sixth graders, welcome to this video here on ClassNotes. So we move on and talk about divergent boundaries today. So the first thing that you'll notice here as I slide myself over is I am back on this doc that we keep coming back to over and over again. The title, ClassNotes, Plate Tectonics 6H. This is what you should search for in your drive to open up the doc instead of trying to find it in Google Classroom because it's from a long time ago. So it's going to be hard to find on Classroom. So go to your drive and do a search for ClassNotes, Plate Tectonics 6H. We've done Roman numeral 1, 2, 3, 4, and 5. Okay, and so today we are moving on to divergent boundaries, Roman numeral 6 down here. We have letter A to go through here as well as then this chart. So if you need a second, pause the video, find that, open it up, and come back to the video. Now that you have your ClassNotes document open, I'm going to go over to my presentation here, and we're going to talk about divergent boundaries here a little bit. All right, so a divergent boundary is another plate boundary, but in this case, they are moving away from each other, and so they are being pulled in opposite directions. So it's a place where two plates are pulled apart. And the reason they're pulled apart keeps coming back to the same thing over and over again, and that is the convection currents that are happening in the mantle. And so when we did our Rice lab, for some of the classes, you actually saw two convection currents in your beakers moving in opposite directions. Those are the type of convection currents that we would see here with a divergent boundary that would be pulling then the plates in opposite directions and pulling them apart. As we go through this here, just kind of pay attention to the graphic here on the side. This graphic on the side is going through the stages of what happens when you are at a divergent plate boundary and the steps in the process of how oceans form. So what begins is that you get this crack, okay? And we call this a rift in the plate as it starts pulling apart. And that rift is going to, as it spreads apart, there's going to be molten material that comes up and renews that gap or fills in that gap. And that's new crust, okay? So this new crust comes up because it's forced up through that rift. And it's like a volcanic eruption, except it's not like a volcano. It's not a tall volcano. It's like it's coming out of the ground, okay? This can happen on continental plates that are being pulled apart, which means it would be on land, or it can happen in the ocean, on the ocean floor. And that's where seafloor spreading took place. When we talked about seafloor spreading before as evidence that the plates were moving, it was at a divergent boundary where you saw seafloor spreading and these rifts. The next step is that a rift valley forms. And so you get a valley, which is this low elevation area, as it's being, the plates are literally being pulled apart from each other. So you have this little valley area. It's weakening the crust a little bit more. And then over time, that area begins to fill with water. And that's how you get an ancient ocean, and then an older ocean, and then you get ocean. And even more important than that in terms of plate tectonics then, is the fact that underneath the water, you can get these long underwater mountain ranges that are called mid-ocean ridge. You guys did a homework assignment a couple weeks ago about Marie Tharp. Marie Tharp was a geologist who is credited with kind of discovering the huge mid-Atlantic ridge on the ocean floor. And that helped to prove seafloor spreading and continental drift, the whole drifters thing, which is a pretty interesting and unique story. So that's kind of the process of what's happening at the divergent boundary as the plates are spreading apart. As much as that's important, this whole unit, and I keep referring back to this, is more so about cause and effect. So we've talked before about because of the heat from the core, you have convection currents in the mantle. Because of the convection currents in the mantle, you have plates that move. Because the plates that move, you have these different geologic activities that take place, like the formation of a rift valley or the formation of a mid-ocean ridge. And that's a direct effect of the plate movement, that is, when the plates are moving away from each other with divergent boundaries. So let's make sure that we fill out this chart accurately so that we know what is happening and what are the cause and effect relationship with a divergent boundary, because this is the stuff you'll need to know for the next test. So I have the whole chart that just kind of popped up here. So why don't you hit pause and copy this in, and then I will then come back and listen to me kind of go through and explain differences between what happens at oceanic plate boundaries and when it's continental plates that are being pulled apart. So pause the video, type this in. All right. Now that you have this typed in, make sure that we're listening here so that we understand what's happening. So let's start first with our plate boundary where it's in the ocean, okay, an ocean floor. So the ocean floor is pulled apart by the convection currents, and magma erupts, and you start to form this rift and this rift valley, and eventually enough volcanic activity happens that it builds and builds and builds and builds and builds on top of each other, causing a ridge, mid-ocean ridge. And probably the most famous one, the best example, is the Mid-Atlantic Ridge, which runs right through the Atlantic Ocean. For continental plates, when they are being pulled apart, the land is being pulled apart. And what we start to see are these rift valleys. And then if enough of the molten material can start to build on top of each other above the land, you can actually then see some volcanic mountains. So volcanic mountains are usually like the mountains we think about, or I'm sorry, the volcanoes that we think about when I say volcanoes. Think of kind of these things that look like mountains, but they can erupt lava. So you have volcanic mountains. You can have rift valleys. And good examples of these are the African Rift Valley, which is in, what would that be, Eastern Africa. And then the actual country of Iceland. Iceland is actually there because it is on a divergent boundary. And we'll have to talk a little bit more about Iceland because it's a super unique place, okay? And it's super unique in terms of plate tectonics and geologic features that make it really, really interesting. Here's a picture of the Mid-Atlantic Ridge going through the Atlantic Ocean. I want to show you guys Google Earth in class to show you that you can literally, from the satellite pictures out in space, you can actually see the ridge under the water. That's how big and massive it is. Okay, here is the African Rift Valley. And so you have, I know it's a little bit hard to see here, but you have these fault lines in red. Okay, and what is happening here are these lakes are starting to form, and this water is forming there, is gathering there because you have created this Rift Valley. So because it's a lower elevation area, water drains there and begins to fill it up. So you start to get these lakes, and it's literally the ground being ripped. Okay, it's like being ripped apart. Okay, now divergent boundaries are usually the easiest. So we start with divergent boundaries. Actually, I shouldn't say that. Transform boundaries are probably the easiest. But divergent boundaries is a nice place to start since we've already talked about seafloor spreading. And this is, seafloor spreading is because of the divergent boundaries on the ocean floor. And so it's a good place to start for us. So that's it for the video today, because I don't want to go through on the video and show you a couple. I have another video to show you about the African Rift Valley. Excuse me. As well as then Google Earth to show you. All right. Make sure you get these done, and I will see you next time in class. Thanks for listening.